Okay, so again we start with the constructing the shear force diagram. So sorry. We go backward. Okay, so now we have the force is a triangular shape. We start with the force that is triangular shape. So the force we said if it is downward is positive or negative that we have to know. We have to memorize it. Okay, downward is negative. Okay, downward is negative. So the loading, is it increasing or decreasing? Is decreasing. Okay, so which side of, let me draw the circle. Okay, we have a negative. We have a negative and decreasing, which means this is the negative that is increasing, and this is the negative that is decreasing. That is decreasing. Okay, negative decreasing is this side of the curve. So I'm gonna construct it based on this side. So I'm gonna construct it, as you could see, this side. I'm gonna choose this side of the circle. So you see, my curve looks like this. Exactly looks like this. Okay, looks like this. This part of the circle. You place it here. How much of the shear force do you have? How much of the shear force? You calculate the reaction. Upward is positive, then you get the positive. Okay, so now the shear force is positive. What I do, is it positive? I specify. Is it positive? Yes. So that means I have two slopes based on this circle. Let me clear this. This, sorry. Let me construct it again. So I have positive, yes. Is it increasing or decreasing? Is decreasing. The thing is decreasing. Okay, decrease positive. This is decrease positive. This is positive and it's decreasing. Okay, so this is positive decrease. So this side of the circle would be my graph, and we could see that this side would be, sorry, admitting students. Okay, this side, let us see, is it this side? Is it this? Yes, exactly. This is the side of the circle. Okay, so this is the side of the circle with which I could construct my bending moment diagram. So I have constructed the shear force, the bending moment diagram so easily just by memorizing few things: positive, negative, and the distribution increasing or decreasing. Okay, so that's how I constructed all my diagrams. I get the reactions and then I construct the diagrams. That's all what I need to do. If you have a question, you could ask. If you have a question, you could ask. So now we can develop for any shape, for any type of forces. We could construct the shear force and the bending moment diagram. If you have a question, you could ask. Okay, over here you have uniformly distributed. Over here, it's not uniformly distributed. So we can construct based on the concept. We memorize things. We need to memorize slope, positive, negative, increasing, decreasing. That's it. Okay. When the force is constant, then the slope is constant. Okay. The line is, I mean, we don't have a curve. When the force is constant, when it doesn't change, there's no increase or decrease in the loading, then that means we have two choices. If the load is downward, that means negative. So we have, let me show you the notation. So if we have like the force is downward, negative, so the slope would look like this. This is negative if downward. If the slope is up, if the force is upward, so that means it's positive, is negative. Sorry, is negative. Downward is negative. Upward is positive. So and it's constant. So the slope would be positive. Okay. It's all about you memorize. You memorize how you what positive is meant by, what negative is meant by, what constant is meant by, and how you could construct it, and what if it is not constant, then it's decreasing or increasing. On the circle, you look at the slope, on which side is decreasing if it is negative, and if it is positive, on which side is increasing or decreasing. So the same thing for positive and negative. That's all. If you have a question, you could ask. If not, we move to another question if you don't have a question. No question is not a good thing, though. What to do if you have no question? I also have nothing to say. So we go see how many examples left. This over. Okay. We have this example. This is we have this example. Okay. So we construct the shear force and bending moment diagram so easily. We go to the solution immediately. As I told you, we have we look at we have a simply supported beam fixed at B side, and you have a uniformly distributed load and a point load. So you have a combination of a force that is uniformly distributed and a point load. So we could see how we could construct the shear force and bending moment diagram. The same thing, we always start from left to right. So we start from this side. So on this side, immediately I will have a force acting downward. It's like you are having a reaction. Okay, this looks like you are having a reaction at this end, though it's not. It's a load. So the load would push push it downward. Okay. Okay, because the shear force would be upward. Shear force upward means negative. So the force, if it is acting downward, so it would push the diagram downward. Okay, that's one. The other thing, do we have any forces, any in between this point load and the distributed? Within this zone, there is no force. So the shear force is constant, nothing to disturb my shear force. There would be nothing to disturb my shear force. Because if the force is acting downward, so the shear force, if I take a section, the shear force at any section is the same, is equal to 2. So I have a straight line from this point prior to the distribution point, prior to the point where the distribution load starts. So prior to this load, prior to this point, you will have no change. Okay. Once you start to have this distributed load, again, as I told you, if the force is downward, we have to memorize this. If the force is downward, did I say negative or positive when the force is downward? Is it positive or negative? It's negative, right? When the force is negative. So we keep in mind as negative. The force, does it change? Does it increase or decrease? No, it's constant. So the slope is constant, which makes it looks like this. The slope would look like is negative. So this would be the negative. So I start to construct it from here. I will develop this. This would be the shape. How much is the value over here? It's 5. It's 5. I have it. Okay. So the reaction would close the diagram. The reaction goes upward, so it would close it upward. So I have it here. Also, is closed because the shear force is upward is 2, so it's negative. So it's closed by the force. How it is closed? The force goes downward. Okay. Over here goes upward and get it locked. So once it constructed this way. Okay. Constant, no change. And then here you have the forces acting downward. You memorize it, negative. Okay, how my negative slope looks like this. This is my negative. Okay, then so the line would look like this is negative. The slope of this line is negative. Okay, the slope of this line is negative. The end value, it depends on the reaction. the end value. If it is 5, then 5. Okay, then so that we have the diagram locked. Okay, that's all. So now we move to the bending moment. Bending moment, we make use of the shape. Okay, now we have over here, we need to eliminate this. Okay, now we need to calculate the reaction, like the moment. We calculate it and we have values, we get it. That's it. We have one end is fixed, so nothing else. So we look at this shape. Is this negative? Yes, we have to specify it negative. So we need to specify negative. This zone is negative. Okay. Is it decreasing or increasing? No, it's neither increasing nor decreasing. So it's constant. Yes. So the slope is negative. Yes. So it would be a line with a slope. And it would look like this because negative. This is a line with a slope. This is how the moment would look like. Now I have finished this. Now I go to this. Okay. To this side. Okay. I don't care now about how much of moment do I have. -4 or -5, 6 or 12 or 100. I don't. All I need to construct it and see how it looks like, the shape. And then afterwards, I specify how much the value is. Okay. Now I have a negative. Negative, yes, negative. Is it decreasing or increasing? The negative. Is increasing. Oh, I see. So let me draw the circle because I need to show you so that we can memorize it nicely. Okay, so it's negative. So all what I need to think of this, sorry. Let me draw a line. Okay, I need to think of this slope because negative or this one. Okay, this is increasing. So increasing is this side. Increasing is this side. So that's it. I know. This is not, this is the one. So I need to draw this part of the curve. Okay, this is the part of the curve. I draw it. I don't care, -11, whatever the value is. Okay. Now, how could I know the value? I determine the value. Okay. The value at this point, we can easily, if you calculate the area of this shear force diagram up to this point, that would make it the area, as we said, we take the integral, which is the area, is not the integral, just take the area, okay, of the vx, okay, integral of vx dx, okay, is equal to delta m, is equal to not m, delta m, okay, delta m. So do we know how much of m we have at the beginning? Yes, it's 0. So that means delta m would represent the second value, which we take the area of this shape, which is 2 times 2. 2 times 2 means 4. Okay, we know it's -4. So now I know I can determine the area of this shape. Okay. How could I determine? I have it. I have this. How to say? This is composed of 2 shapes. We have a rectangular shape, triangular. You get these 2. Okay, you get these 2, and you're gonna get delta m for this zone, for the second zone. So once you get delta m, you can know the second value for the m. Once you get delta m out of this, you're gonna get delta m out of this area. You label it as 2. Okay, and this is 1. So once you get delta m, then you will know the difference between this value and this value. So you add the delta to 4. You're gonna get 11. Okay, you're gonna get 11. And then you lock it. Okay. If you have a question, you ask. Even for the shear force, I didn't tell you, even for the shear force, you could do the same. For the shear force, you could do the same. For the shear force, you could do the same. How you could do the same? We have, I told you that the force is constant. The shear force doesn't change. So this doesn't change. Okay, now I need to know about The value is 2 is easily, you could easily know it. You don't need to, there is nothing to calculate from the force diagram. Only all what you need is to know that you have a shear force acting opposite to the force, the external force. So that would make the shear force equal to 2. Upward, we have assumed upward to be the positive, sorry, the negative. So negative, that's it, up to this point. So after that, we have a, what do you call? We have a uniformly distributed load. So if I get the area of this uniformly distributed load, which is 1.5 times 2, 1.5 is the height times 2. If I get the area, that means I'm gonna get the W is like Wx dx. Okay, I get the integral as if I'm getting the integral. So that would be equal to delta V. Okay, delta V. So how much is 1.2 times 1.5 times 2 is 3. So 3 added to 2 would be 5. So I know the values just without having any equations. Without having any equations. Okay? Without having any equations, I've got them. Okay? So if you have a question, you could ask. If you have no question, we move to the last example. And that would be the end of today's lecture for this week. Okay. Any question? Any question? If you have any question, please let me know. If not, we move to the second example. Okay, it seems no question. Then we move to the following example. This is the one. Okay, this is the one. Okay, now we have a simply supported beam. So we calculate the reactions. Okay, we have no moment at these two supports. The only thing that we need to specify how much of reactions we have. We have two, both of them, I expect them. One is to be upward, the other one downward. And we look at the solution and see how is it. Yes, as I said, one upward, one downward. Okay. Now we construct the shear force diagram. If we have the reaction is acting downward, the reaction is acting downward, okay? The shear force is acting upwards. If the reaction is acting downward, so the shear force, if you take the cross section, the shear force would be upward, right? So shear force acting upward is positive or negative? If the shear force is acting upward, would it be positive or negative? If the shear force is acting upward on the section, on this side, is it positive or negative? Hmm? Then yes, is it positive or negative?
Negative أستاذ shear
Negative.
force.
So we specify the negative side for the shear force diagram. Okay, from A to this point, okay, to B, we call it B. Is it B? Yes, B. So from A to B, is there anything that would change my shear force? No. So how much is the shear force? Is equal to the reaction, but negative. So negative 2, I specify negative 2. All the way up to where? Up to this point, when the shear force. Well, prior to this point, in fact, we have two things that would disturb the shear force. One is the reaction, the other one is the force, okay, the reaction. So we look at the shear force is a uniform, it's not a point load, so it wouldn't change immediately. So what I have, the reaction would change the shear force immediately. There would be a jump between, because of this reaction, there would be a jump. The uniformly distributed load would take its effect along the x-axis because we don't have a concentrated load at one point. We have a uniformly distributed load. So the further you go to the right side, the more the influence or the effect of this distributed load would be on the beam, on the shear force. Okay. So there would be a jump, and the jump would be upward with the reaction. So 10 So if I have like 2 and all of a sudden it jumps, how much it jumps? 10. So 2 in the negative, what is left? 8. So it goes up to 8. So I I had a jump up to 8. So now my shear force is here. What I have of distributed load is acting downward. The downward is positive or negative? If the force is downward, we have to memorize it. It's not something that you could comprehend. It's something you memorize it. If the external force is acting downward, does it make it positive or negative? Negative.
Negative.
Yeah, negative. So negative. So I think of negative and the force is constant. So there is no change. So the slope is negative. So the slope is negative. It looks like, should be looks like this. So I construct this. Okay. So now I need to know if this, what do you call this inclined line would intersect with the x-axis. So if the value over here is 8, I know if it's 8. So I need to calculate the delta of, delta V is equal to the area of this force. So that is 4 times 2, 4 times 2 would be equal to 8. Yes, so that would close it. Yes, so it would intersect with the x-axis. So I'm done with the shear force. I'm done with the shear force. So if you have a question on this, you could ask. If no, we move to the bending moment diagram. Okay, seems no question. So we move to the bending moment diagram. So all what you need, as I told you, just memorize the sign convention and so forth. So I need to again specify negative, positive. So I have negative, yes, negative. And then I rely on my shear force. This is positive. Yes, okay. So now I have negative. Negative, and that means the slope is negative, and the force is constant. It's neither decreasing nor increasing. So it looks like this. Negative slope looks like this. So it should be, this should be, this is how it looks like. So how do I know the value if I want to put a value over here? The difference between, sorry, the area of this shear force would be the difference between this value and this value. So this is 2 times the distance is 4, so that makes it 8. So what do I have in the moment at this beginning? There is no moment, so 0. It starts from 0. So the difference would make that the value of the moment would be equal to 8 at this point. A negative, okay, negative. So it doesn't give a smiley face, okay. And then now, what do I have? I have a triangular shape, okay. Is it in the positive side? Yes. Oh, so I need to construct my circle to know what, sorry, I need to construct my circle and think of the positive. I have this positive, this is positive, and this is also positive. Okay, let me check. Is it increasing or decreasing? Is decreasing. So that would be the zone that I need to, that is the zone that I'm gonna make use of. So this part of the circle would help me to draw the bending moment diagram. Yes, true. That's it. Okay. So I need to know that the difference, would it get intercepted? Would it intercept the x-axis? I need to calculate the area of the shear force of this triangular shape. So the area of Vx, integral of Vx, okay, dx, okay, from here to here, it should be equal to what? To delta m. Okay, do I have the m over here? Yes, it's negative 8. So I need to calculate the area, which is the space, okay, half of this space, half of this 4, 6, that means how far is this? 4 to 6, that means it's 2. 2 times the height is 8, right? So I'm gonna get how much? I'm gonna get 8. So delta m is 8. So I have here 8 negative, so that means here is 0. Oh, good. Okay. So that's how we draw, okay? That's how we draw the, what do you call the shear force diagram, bending moment diagram graphical. Okay, you need to memorize, if the force is downward, upward, positive, or negative. There's nothing intellectual about it. All what you need to memorize if downward, is it positive or negative? Negative, of the force. If the shear force is negative, that means the slope. It has to do with the slope. If constant, then the slope looks like, as I told you, if constant, the slope would look like this. Okay, that's the line. Okay, positive. If the negative, looks like this. If it is a curve, we have about two choices for each, for the negative and the positive. Okay, and then for the positive, we have these two. These two are positive. Okay, these two are positive. For the negative, these two are negative. And then we look at the shape. Is it decreasing or increasing? So if it is positive, decreasing, so that represent this part of the circle, which represent the shape of the following curve. If it is positive and increasing, this part of the circle would represent the shape of the, be it moment or shear force. If it is negative, then if it's increasing or decreasing, it depends. Negative, if it is increasing, then this circle, this part of the circle, would represent the shape, and if it is decreasing, this part would represent the shape of the either bending moment or shear force diagram, depends on what you are drawing. Okay, so that would be the end of the graphical method. What is left is a practice for you. You could consider it as a homework. If you have a question, what is left is like you have one, two, three. You have three examples. You could practice on them. Okay, practice on them for yourself. So you solve it on your own. You solve it on your own, and that would be the end of today's lecture. The end of the shear force and bending moment diagram. If you have anything to ask, you could ask. If not, then I just take your attendance, and that would be the end of today's lecture. If you have no question, okay, no question, then we go to attendance. Let me check. Ahmed Bafir,
بله.
Afnan,
بله.
Anjir,
بله.
Bilal Amir,
بله.
Bilal Muhammad,
بله.
Bina,
بله.
Bahra,
بله.
Khalid,
بله.
Dunya, Deniz,
بله.
Ramia,
بله.
Reba,
بله.
Zaim,
بله.
Gila, Sazan,
بله.
سينا ديم وابدا مشكلة هي سنة
بله.
يبو وتي بالي
سینما مست.
سينا زانم اوكي سينا سنة شاد
بله.
شيار
بله.
معصومة
بله.
مهتاب
بله.
مهند
بله.
Haka,
بله استاد.
yeah,
بله.
Asrin Desko. Asrin Desko. Yani Asrin Kazım.
بله.
Didar Avni Namdi. Sertiymişti. Okay, that's all for today and for the topic as well. If no question.